Hi, I'm Jonathan from Lightwheel, and today I'm here with Francis Williams, and he's going to talk to us about fVDB, and that's Gaussian splatting, and he's the expert here. He's going to give us a little bit of a live demo of the research that they just went live with. Francis, it's nice to meet you.
Nice to meet you too.
All right, so can you give us just a brief overview of what fVDB is?
So fVDB is a library of data structures and algorithms that's built on top of PyTorch for deep learning and processing of volumetric data. In particular, volumetric data at very large scales and very high resolutions. So think everything from simulation data like fluids, fog volumes, to Gaussian splatting, to meshes, really you name it, fVDB can handle it. And on top of that, we also have this fVDB reality capture toolbox, which is a toolbox for doing reality capture on fVDB because, well, when you're doing reality capture, you often want to deal with large and high resolution data.
Okay. So I'm seeing, as I look at this, it looks like a point cloud, Gaussian splatting, triangle mesh. So this is all image-based, correct?
Yeah, so in the demo here on the left, this is a drone scan that consists of 177 images on an $800 DJI drone.
Wow.
So it just kind of flew around. The point cloud you see is what you get out of a structure for motion pipeline, so just kind of off the shelf. From that we go to a Gaussian splat, which you see in the middle, and from the Gaussian splat we actually extract the triangle mesh. So everything is derived from those 177 images. And one of the key features of fVDB reality capture is the fact that the sort of default parameter settings have been very tuned to work on kind of any input, right? Okay. So things from your large-scale drone data to indoor data to you name it.
Okay.
Yeah.
How reactive is it to, let's say I have some exposure issues, maybe I forgot to lock the exposure in my image, and is that something that it compensates for, or do I have to really nail these images to get a good output?
I mean, you can use there's exposure compensation for sure that you can turn on and off, and that'll help in the same way that exposure compensation in most Gaussian splatting pipelines.
So this was only a few hundred photos, or under 200 photos. Could I throw 2,000 photos at it?
This is 4,000 photos over 10 square miles. And this is actually 100 million Gaussians.
Wow.
And the viewer here that you see, it's part of the fVDB viewer package. And this is all running a browser. Okay. Off of a 3090.
Off a 3090?
Yeah.
Okay, so this is not even a new GPU. This is several years old GPU.
Yeah.
Okay.
So this streams the visualization to the browser. Yeah.
Okay.
So really, that's the point, right? We can scale up.
Okay.
Yeah.
So if I was wanting to get started and playing with this, how would I go and find this?
So you can go to fvdb.ai or fvdb.ai/reality capture.
Okay.
Which I can kind of show you here for the reality capture website. There is, of course, an explanation. There's very detailed tutorials, both if you're kind of a hacker and want to script all of this in Python, blah, 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 with interactive visualizations. But also if you just want to reconstruct something, you can use this frogs command, which stands for fVDB reality capture Gaussian splatting. So, frogs reconstruct, and then you pass in your data, and then you get out currently a PLY or a USDZ file.
Okay.
But we'll have support for SPC and other formats going forward.
So would you, let's say you have a 3080, even not a 3090, is that good enough hardware to train these?
Yeah, it should be. I mean, your bottleneck usually on this is going to be memory, right? So to go to 100 million or 200 million splats, that's not going to train on a 3090. But one of the key features of fVDB that's currently, this feature is in early access, but will be released in an upcoming version, is multi-GPU scaling.
Okay.
And so the idea is that you can take exactly the same code that works on a single GPU, you can add a second GPU, a third GPU, a fourth GPU, and it will just scale horizontally across all
That's great. So I could deploy it to a cloud and have eight GPUs running and getting probably...
Yeah. So it's
really fast output.
The size that you want is just proportional to the hardware that you have, which I think is a much more user-friendly experience than trying to do chunk and stitch and all these other approaches. Yeah.
So then at the end you end up with this amazing scene, this 3D Gaussian splatting. Is it compatible with the OpenUSD standard, where I could perhaps put it in IsaacSim
Yes.
or a different?
So maybe to show you, we have a live demo here. So again, this is that 177 images that we captured, and we extracted a mesh, which we're using as collision geometry. And you can see here we have this tiny little spot robot that you can actually walk around.
Oh, wow.
So it uses a locomotion policy. It's
just a PlayStation controller.
In IsaacSim. Yeah.
Yep.
And so again, maybe the visual fidelity on this is not perfect, but the idea is really that you can go from like very little to something that is actually interactive. And here, if you want to drive, go for it.
And in reality, a robot like that is not looking at this world in 4K. It just needs to be accurate enough to know, hey, that's a walkway, that's a building, don't walk into that, avoid this.
Yeah, exactly.
All right.
And of course, you could always take a bigger capture or use generative models to
That's
up
cool.
the fidelity. But we really wanted to show that it just works,
That's great. So you can go easily just from images to kind of build your world for robotic simulation or VFX, whatever your end goal is, and you can start as little as 1 GPU to eventually, if you need to be doing this at scale, you can be hitting 8 GPUs or a DGX cloud.
I hope that one day we'll do a radiance field of an entire city or an entire state on a huge GPU cluster. So
it's probably gonna happen sooner than we all expect.
Yeah, I think so. I think that'd be really, really cool.
All right.
Yeah.
Well, thank you for your time, and
of
I look forward to getting my hands on this and making some
please
tutorials
do.
around it.
Yeah, thank you.
Nice to meet
meeting
you.
you.